My name is Melissa, and I am currently a middle school math teacher. I have taught mathematics to both students in elementary school and middle school in various settings over the past 8 years, and I am eager and excited to teach during the VSA Summer Camp program this year. The math vision for the VSA Summer program is to achieve student success by developing students' interest and confidence in math through mathematical thinking, creativity, and problem-solving skills, and by learning that is based on concept and principle understanding. The three ideals of this program is that it is intensive, it is interactive, and it is engaging. By intensive, the VSA program allows for skills to be taught and reinforced daily. Students will have the opportunity to hear skills, see skills, and have ample time for practice. Interactive means that in a VSA program, students will be actively engaging in the material with their teacher and their peers. Students of all ages will be practicing as they learn and sharing their thoughts with the class. Finally, classes are engaging because they are visually appealing, fast-paced, and exciting to make students happy and ready to learn each day. So our math class format, the daily classes are 45 minutes long. We start with a 30 to 35 minutes for instruction on the math skill, and then we allow about 10 to 15 minutes for skill practice. But students are practicing as the lesson is going on. Students use an interactive slideshow platform and complete online math exercises for skills practice. And what's really special about this program is that teachers see student progress and work with students who are making errors. So as the teacher, I can see students work in real time, which is really effective because I can catch mistakes as they're happening and keep that from becoming a habit. So before students ever get a chance to finish that mistake, they already are able to correct it. Each week, students are introduced to 1 to 2 new skills and 1 to 2 different math disciplines based on the complexity of the skill. So if the skill is really challenging, we might work on it for the whole week. But if it's something we can get through a little bit faster, on Monday and Tuesday, students might work with one discipline like fractions, and then on Wednesday and Thursday, they might work on something like measurement. So this is what the teacher view of the program would look like. So as you can see on the left, I have the questions that's being asked, and then I can see each student's work in real time. So my screen's populating as the students are writing. They can draw, they can use text features, and it's really amazing to be able to see what the students are doing as they're doing it, and I can really get insight into their thought process. So once it's time for the more independent practice portion, this is what my screen would look like. So as you can see, I can see the whole class at once. I can see what the skill the student's working on. I can see their score. I can see what they're getting right, what they're getting wrong. And then if I notice a student needs additional support, I can click into that student, and then I would see a screen that looks like this. So I can see what question was being asked, what the student answered, what the correct answer should have been, and then help as needed. So for kindergarten through grade 2, this is kind of what the skills that would be covered throughout the summer. You'll notice that it's a spiral curriculum, meaning that students might be introduced to a skill in kindergarten. Then as they get into first grade, the skill is going to get more challenging. And then the hope is that by second grade, the skill is mastered. So you're going to see things like counting and skip counting, addition and subtraction, even and odd numbers. You'll see 2 digits, 3 digits, money, telling time. So you get a really just well-rounded understanding of all the different ways you might use math as a kindergarten, first grader, or second grader. As you can see, the kindergarten slides are really colorful. They're really engaging. They're appealing for the students to look at and work through. Here's an example of what a first grader might see. As you see on the left, if a student's learning subtraction, they're seeing a real world problem. So how would I use this? They're seeing the standard algorithm. So how can I solve it? And then they're seeing a visual representation of why this is how I solve it. And we learned that once students understand the why, they can really commit the understanding to their long-term memory, and then they can use the skill long past the class. And then here's an example of what a second grader might see. For grades 3 to 5, the spiral continues. You'll see third graders, fourth graders, and fifth graders using addition and subtraction. As they get older, they'll start being introduced to fractions and decimals. They'll see geometry, they'll see customary and metric units, time, and then you'll see, as you see the skills repeated, they're getting more and more challenging and requiring more and more steps through each grade. Here's an example of what you might see if you're doing multiplication. So we really stress that students know their multiplication facts, but also understand what multiplication is. So it's more than just 4 times 5 equals 20 and I memorized that. It's why is 4 times 5 20? And we feel that that really helps students understand, and then it really helps them remember. Here's what a student might see for division. So you can see that the students will see it visually. They'll see the proper vocabulary terms, and then they'll see the standard algorithm. Here's an example of students, how they might work with numbers. So you'll see that they'll do place value, they'll learn standard form, word form, and expanded form. Another thing that we really stress through our math program is the word problem process, because we find that, once students understand how to solve a problem, they know how to add, they need to learn when to add and why we would add. So for our word problem process, we always start with just a baseline reading, having students underline the question, label the units for the answer, and then envision the problem and really figure out, what am I doing here and what skills do I have that can help me solve this? Then we encourage the students to read the question a second time before they even try to solve, have them circle the information they need to solve and determine what is being asked, what do you already know from the problem, and what do you need to know in order to solve the problem. Then finally, once the students have read the question twice, we encourage them to sketch or make a table or a diagram to help them solve. And then finally, once they have their answer, read it one more time to just check and make sure you have everything you need to do, and then identify each step and its equation. Here's just an example of how we connect whole numbers and decimals when we introduce decimals. And then finally, for our oldest students, we have our pre-algebra, algebra, and geometry courses, and here are some of the skills that you'll see. Obviously, since the courses differ, you'll see more skills overlapping pre-algebra and algebra versus geometry. And then here's an example of what the slides might look like. Even with our older students, we really stress being able to be able to see it visually, being able to do the standard algorithm, and just truly understanding what you're doing. Finally, our goal is that each VSA student gains the computation and problem-solving strategies to approach any math problem with confidence in the appropriate tools. We hope that math problems become attainable and accessible, and that students will approach multi-step problems with the ease and confidence that they would simple computation. So our hope is that the more confident our students get, the less daunting word problems become, and they can just, approach it with the same ease that they would if we were asked them 2 + 2. We want students to be able to organize their mathematical thinking and explain that thought process to a peer. We want students to have a strong grasp on grade level mathematical content and gain the skills necessary to apply the concepts to any questions. And then finally, similar to what Emily was talking about in language arts, but that students foster the ability to check for reasonableness, meaning my answer makes sense, complete an error analysis, meaning that I can look at my own question and see, wait, maybe I made a mistake, and then correct any mistakes they are solving on their own. And thank you so much, and we really look forward to working with you this summer.